This is the notes for section 10.8, Law of Cosines. If you haven't done so already, make sure you pause the video at this time and read the section before continuing on. In 10.7 we looked at the law of sines, and we said we were using the law of sines to complete triangles, and we used that in situations where we had a triangle where we knew angle, angle, side, or angle, side, angle. Today we're going to look at law of cosines, which is a similar idea. It's a little bit more complex formula, but it's similar in that it allows us to complete triangles. And the situations in which we're going to use the law of cosines is when we have a side-side-side situation, like right here, or a side-angle-side situation, like we have right here. Okay. Now in your book they go through a proof for the law of cosines. I'm not going to spend time with that proof. We can maybe talk about it a little bit in class, but I'm going to just present what the law of cosines is. And it just basically says that we can say that c squared is equal to a squared plus b squared minus 2ab cosine of c. Now, as I look at that, I'm looking at c as being the side opposite angle c. So when we're setting up law of cosines, it doesn't matter what your a, b, and c are, as long as we're keeping in mind that the angle c is opposite the side c. The angle a is opposite the side a. So I could rewrite this. I could do the exact same thing here, but say that a squared is equal to c squared plus b squared minus 2bc times the cosine of a. So notice I'm always going to take the cosine of the angle that is opposite the side that I'm trying to find. Okay. Now I mentioned that we can use this in side-side-side situations and side-angle-side situations, and we can really solve for either an angle if we know all three sides, or we can solve for a side if we know two sides and an angle. And we'll look at an example of each of those here in just a little bit. Alright, before continuing on with example 1 here, you might want to take a minute or two on page 707 to read through example 1. This problem refers to that and is a very similar type problem to what you're going to see in that example 1. Alright, in example 1 it says, suppose that two straight roads meet in Canton at an angle of 38 degrees. Anton is 11 miles down one road and Banton is 5 miles down the other. How far apart are Anton and Banton? Okay. Well, I have a picture of this drawn over here. Check yours, make sure you have the correct measurements on there. So if this would represent 11 miles, this is your angle of 38 degrees, and here's your 5-mile road. Now you'll notice that I have a side angle side situation, which will allow me to solve for what I'm looking for, the distance between Anton and Banton. Okay, so if I'm trying to find that distance, that's over here. I can use the law of cosines to go about doing that. So what I can say is I'm going to call that c. Therefore I'm going to say c squared is equal to a squared plus b squared minus 2ab times the cosine of c. Okay? So now I'm going to plug in those things that I know. I don't know what c is, so that's what I'm trying to find. A squared and b squared are 11 squared plus 5 squared. It doesn't really matter which one's which there. And then I have minus 2 times, I got a and b again, so that would be 5 and 11. And then times the cosine of c, which is 38 degrees. Okay. Now, if I want to find c, I'm going to take the square root of all of that stuff. So c is equal to, now this is what I'm going to enter into my calculator. So now I've entered that in my calculator here. It's always best to put it in as one calculation so we don't have the double rounding going on. Now I'm going to go ahead and I want to get an approximation to that, so I'm going to hit Control Enter, and we'll see that it's about 7.7 miles. So my value over here would be 7.7 miles. Okay, so there's an example where we had side angle side, and we solved for that missing side, that third side. Let's take a look then next at example 2, where we're going to solve for an angle. In example 2, we have a situation where we have this triangle over here, and we have two of its sides, and it's an angle. The angle is not included between. This is what we would call a, if you can remember back to geometry, a side angle, where I have the big S and the big A. Big S stands for that the longest of the two sides that we know is opposite the angle that we know. We can also use the law of cosines for these type of situations. So let's use the law of cosines to solve for Q here. So I'm going to set this up. Now, since I know this side is opposite this angle, I have to, this has to kind of be my C, and this has to be the angle opposite angle C. So I'm going to say 18 squared is equal to the other two sides, 10 squared plus what I'm trying to find, Q squared, minus 2 times 10 times Q times the cosine of the angle that I have there, which is 45 degrees. Okay? So now what we need to do is we need to solve that for Q. Now to solve this one, you'll notice that I have a Q squared and I have a Q in here. So really, if I were to simplify this, I would be solving a quadratic. So this is going to be the type of situation where I have, if I'm solving one of these sides, big S little s big A situation, you can go ahead and put this in your CAS and use the solve feature to solve that. Now we could simplify that and solve it using the quadratic formula. It gets a little bit messy, so I think this is one where it'd just be better to go ahead and use the solve feature on your CAS calculator. So if we come over to our CAS, I put in solve and I put all that in. Remember, you're going to solve for Q, so you got to put comma Q in there. Now you'll notice the two answers that I get, and I had to get two values. One is a negative value and the other one is about 23.6. The reason why we're getting two values there is because we have a side angle. Now the negative value we know is not true, and once again, the other thing to think about it, we know that this is a quadratic, so we should get two values for Q, but you'll notice that I have a negative value, so really the only one of those two values that works is the positive value. I can't have a negative value for that missing length. So the answer here would be the about 23.6. So let's write that out over here then. Q is approximately equal to 23.6. Okay? In my third example here, I have a situation where I have side, and I'm trying to solve for a missing angle. So we're asked in this example to find the measure of angle C. So I'm going to set it up in such a way that if I'm trying to find this angle right here, I'm going to start with the 23. So I'm going to say 23 squared, because that's opposite the angle I'm trying to find, is equal to 15 squared plus 18 squared minus 2 times 15 times 18 times the cosine of C. Okay? So our goal is to figure out what C is, so we got to get C by itself. Remember, this is all multiplied together, okay? So we have to be a little careful on how we're going about solving this. So the first thing I'm going to do is I'm going to get this stuff over to the other side by subtracting it. So I'm going to subtract 15 squared and subtract 18 squared from both sides. So I'm left with 23 squared minus 15 squared minus 18 squared is equal to the opposite of 2 times 15 times 18 times the cosine of c. Okay. The next thing I'm going to do then is I'm going to divide by this stuff right here, the negative 2 times 15 times 18. Do that on both sides. Now if I do that, this stuff here cancels out. So I have the cosine of c is equal to this stuff right here. Okay? So if this is what the cosine of c is equal to, then to find c, I have to take the inverse cosine of both sides. Because the inverse cosine of the cosine of c is c. And then that gives me what I'm going to need to put into my calculator. So if I take the inverse cosine of this stuff right here, I'll have the value of c that I'm looking for. So if I do that on my calculator, take the inverse cosine of that stuff, you'll notice that I get about 87.9. Therefore, the measure of angle C would be 87.9 degrees. Alright, finally I'd just like to summarize what we did in the last two sections about this whole idea of solving triangles. So if you need to find the side or an angle of a triangle, the first thing that you want to do is use your simplest methods, possibly before using trigonometry. So if you can use Pythagorean's theorem, whatever you know, whatever the simplest method is, you want to use that first. Okay. After that, if you can use right triangle trigonometry, you'd like to do that. Okay, using your trigonometric ratios, and don't forget about those. And then finally, we can use the law of sines and the law of cosines. If we have angle side angle or angle angle side, we can use law of sines. And if we have side angle side, side side side, or big side, little side, big angle, if I have any of those three situations, I can use the law of cosines.